So let's get the meeting started with Andy and the sky this month.
Hello, my name's Andy Beaton. I'm speaking to you from my horrible basement office in downtown Toronto, and I'm here to talk about the sky this month, from tonight until the next meeting at the beginning of August. As usual, I've got a set list of things I like to cover: the big picture, key dates coming up, the moon, the planets, deep sky stuff, a double star just in case Blake is listening, a variable star because I like variable stars, and whatever's going on in the world of spaceflight. So let's tear straight in. The big picture, this is what we've got. If we get out tonight after twilight and look to the west, we can see that the spring constellations are disappearing. We're losing Leo, we're losing Virgo and Botes and all the stuff there. As you can see, there's very little in the way of planets or interesting interlopers in the evening sky. We've got the moon tonight. We've got a nice crescent moon, but not much else. The planets are all going to be here in the morning. This is the last chance to observe before the next meeting. 5 a.m. on August the 3rd, and as you can see, there's an abundance of planets. And now that we're into July, if you stay up late, you're going to start seeing the fall and winter constellations. I always get depressed at my first sight of Orion observing. I hope you don't, but that's what we've got coming up. And yeah, look at all those planets. Those are lots of planets. In fact, it's a veritable parade of planets. If you're out at 5 o'clock this morning, you'll actually see all of them, starting at Mercury, all the way out to Pluto, way off in Sagittarius. Personally, I don't think Pluto is a planet. Many people do. That's what the disclaimer at the beginning of the presentation about not representing the official views of the RSC is all about. It's me and Pluto. But anyway, if you're out there this morning, you've got Mercury, Venus, Uranus, Mars, Jupiter, Neptune, Saturn, and Pluto all in order there. Mercury is going to be the tough one to see. It's not going to be much above the horizon before twilight comes, and it's going to be disappearing. So if you want to see the full set of planets all at once, then tonight, tomorrow, the next few days are going to be key days for you. If I leave it beyond that, you're going to lose Mercury, and you're not going to see everything all at once. This is a rare treat. The nights are getting shorter. No, that's an error. The nights are getting longer. I should have proofread this. Now that we're past the summer solstice, the nights are slowly getting longer. Twilight is going to end around 11:15 tonight and start again at 2:55 in the morning, which is it's a lousy time for you astrophotographers who are going to want to be out there catching long exposures. But it's going to improve. By the end of the month, twilight will be ending around 10:40 and starting again at 3:45. So things are getting better for photographers and people who like to get early evening observing taken care of. Important things coming up. July 28th is going to be the new moon. The moon is at apogee, which is the farthest. I put that note in there because I never remember which is which. On July 26th and closest on July 13th. It just so happens that July 13th is also the full moon. I don't like the phrase or the term supermoon, but a lot of people do. And if you're talking to people who are vaguely interested in astronomy and don't know very much, don't be afraid to tell them that it's a supermoon and they should go out and see this once in a month special thing. We also have the South Delta Aquariid meteor shower peaking on July 29th. It's not the greatest meteor shower, but the good thing is it's very close to the new moon, so there's going to be no moon problems with that meteor shower. The moon itself, first quarter on July 7th, full moon on the 13th, last quarter on the 20th, and the new moon on July 28th. The lunar X, for people who haven't heard of it before, it's an interesting feature, the intersection of two crater walls. At a certain time, it gets illuminated in such a way that it makes a nice, pretty X on the surface of the moon. It's not scientifically important, but it's a cool thing to look for. Unfortunately, this time it's coming through in the middle of the afternoon for those of us in the Eastern time zone. So if you've got a telescope pointed at the moon, you may be able to see it. I've never tried seeing it in daylight before, but who knows? It might work. So the planets, everybody loves planets. Mercury is visible in morning twilight early in the month, and when we get around to the last half of the month, it'll start appearing into evening twilight. Venus is out there in the morning sky. It's insanely bright. You can't miss it. It'll be the brightest thing you see up there other than the moon. It's heading towards the sun as the month progresses. It'll be there for the full month, though. Mars is getting bigger and brighter in the morning sky. It's getting to be big enough that you can actually see detail. I mean, I remember the last time we were doing this, it was still in the evening sky, and it was small and far away. Now it's getting big enough to see the ice caps, maybe see some surface features if the seeing is good. So it'll be worth looking for Mars again. Saturn and Jupiter. Everybody loves Saturn and Jupiter. Jupiter is rising around midnight. By dawn, it's going to be high in the south. It's going to be a really good time to go looking for Jupiter if you can stay up that late. Saturn rises before evening twilight ends, so it's the first bright planet you're going to see. The rings are still nice and open and obvious. If your kids can stay up till midnight, they will be thrilled at the sight because it's the coolest looking planet for people who aren't prepared for what planets actually look like. It looks very much like a cartoon planet. It's so crazy looking. Uranus and Neptune, the ice giants, they rise well into the morning. Neither of them are particularly close or bright, but they're out there. And if you're the kind of person who likes to see all the planets or as many planets as possible, they're worth seeing. I like Neptune as well because it has a moon, Triton, which you can see with a modestly sized telescope. And in fact, you can even see it from the city with a decent sized telescope. It's a nice concentrated light source. So if you're looking for a challenging object, but you can't get away from downtown, Triton, it's an interesting one. Minor planets, Pluto's in Sagittarius. If you count it as a planet, it leads the planet parade. Unfortunately, 14th magnitude is difficult, and there's a lot of equivalently bright stars around there, so identifying it by looking at is going to be difficult. The best way to do it is either through imaging or making a very careful map of where you think it is, and then coming back a few nights later and seeing if anything has moved. Ceres, too close to the sun to be observed, so we're not going to see that one. The other minor planets, they're of no real interest to us. I don't think I know anybody with a telescope big enough to see them. I like to have a bit of deep sky stuff. This time I'm going for the Great Rift, the dust cloud running through the Milky Way from Cygnus all the way down to Centaurus. It's a cold gas and dust that obscure the stars behind it. It's probably the largest I don't know if you'd call it an object, but the largest thing any of us will ever see. It's insanely huge, massive, millions and millions of stars, um, all smeared out over the center of the Milky Way. If you look up to the constellation Cygnus and the sky is dark enough to see the Milky Way, you'll see it kind of has two bands going parallel. The dark space between the two, that's the Great Rift. That is it. Um, because you need to see the Milky Way to be able to see it, you do need to be outside the city. The farther, the better, or patiently wait for another big blackout. So there's a picture of it. You can see the just that black smear going all the way through the center of the Milky Way. That's it. And if you're, say, a more advanced observer, or you've access to more advanced equipment, there are things to do with it. There's a list of dark nebulae compiled by Paul Gray. It's in your observer's handbook. I know you've all got observer's handbooks. And there's a vast list of dark nebula, almost all of which are part of the Great Rift. If not, nothing is really directly attached. There's bits and blobs all over the place, all part of the same big thing. If you're someone who has equipment to do imaging in infrared, I think that would be an interesting thing to look for, because infrared gets through this the dust and crap better than visual light. You might be able to get a good image of the Great Rift in infrared, compare it to an image in visible light, and look for differences. See if you can see some stars poking through, see if you can see features that don't show up because they're just dark, but might be glowing with a bit more infrared light. All kinds of possibilities. You could also, if you're really advanced, if you're the kind of person who has a spectroscope for their telescope, and I know somebody out there does, try some spectroscopy of the stars along the edges. See if you can find discrepancies in the colors of the stars and their spectrum. See if they look redder than they should because they're just poking through a little wee bit of the Great Rift. Anyway, there's some cool science that the advanced observers out there can mess around with. So we have comets and meteors, as always. The Perseids are coming up. They peak in August. Whoever's doing the sky this month, next month, they're going to get to talk about how bright and impressive the Perseids are and what a letdown they're going to be this year because they're so close to the full moon. However, they do start a lot earlier than that. The Perseid dust swarm will actually start impacting us around July 14th. I mean, we're not going to get dozens or hundreds per hour, but we're going to get sporadic meteors starting around then. And get out there. If you see a meteor, trace it back, see if it points to Perseus. If it does, odds are you're seeing an early Perseid. The southern delta Aquariids, they will peak sometime between. I don't think I have the peak there. I think it's sometime around the break in the month, early August, and they will peak around 20 per hour, about a third of what we expect from the Perseids. But there we've got the new moon on our side, so it will be a much better meteor experience. Minor showers, the Alpha Capricornids, they peak at about 4 meteors per hour. I wouldn't bother going out to see them. They're not going to be spectacular. But if you are out and you do see a meteor, trace it back and see if it points to Capricorn. It may be one of those. And the same goes for meteor dribbles. These are meteor showers where we're looking at less than 1 or 2 meteors per hour belonging to the shower. The Phi Piscids, the C Andromidids, the Zeta Cassiopeids, and the Eta Eridanids, all going through great big long periods. They're long showers, but there's so few of them that unless you really know you're looking for them, you'd never notice them. We have some adequate comets, nothing to write home about, nothing to get too excited, but if you like seeing comets, and who doesn't, they're out there. C2017 K2 Pan stars, 8.7th magnitude in Ophiuchus. C2021 F1 Lemon Pan stars in Eridanus. C2021 E3 ZTF in Carina. These guys are southern hemisphere only. We're not going to see them here, but because we're on the internet here, anybody in the world could be listening to my rambling here. So yeah, if you're in the southern hemisphere, there are some comets there that you can look for and I can't. So take advantage of it, and if you see it, send me a note and do some boasting. Make me jealous. 45P Honda Merkos Padyusakova, 10th magnitude in Leo, and C2021 P4 Atlas, 11.3 in Leo. Those are both going to be tough because they're getting closer and closer to the sun disappearing into twilight. If you're going to go hunting for them, do it as soon as possible because they won't be around for long. Oh yeah, Aurora, Comets and Meteors and Aurora. I've been hearing that could be a minor geomagnetic storm tonight with Aurora on the way. Are we going to get to Aurora? Maybe yes, maybe no. It's always a crapshoot. But spaceweather.com for details. You can get up-to-date forecast information on whether it's happening. In fact, I would bookmark that address and save it. Check it every time you're thinking about going out and looking at the sky just to see if there is some aurora out there. I would like to do a double star, or in this case, a more than double star, Alpha Herculis, aka Rassel-Gethy. I throw that in there because anybody who's ever bought a telescope that does its own aligning, it always tells you to align itself by the star name, and nobody knows the star names, so we'll throw it in there. Hopefully, when you're aligning your telescope and the handset says point it there, you'll remember that it's Alpha Herculis. Anyway, it's a quintuple star. The primary star is a variable star, which obviously makes me happy. 2.7 to 4th magnitude. The B star is 5.3 magnitude. It's pretty close, 4.6 arc seconds. You'll want a decent telescope to be able to split that out. C and D, strictly speaking, they're only visual companions. They're close, but they aren't really part of the system, so it's a bit of a cheat. Really, it's a triple star. If you're interested in variable stars, and come on, who isn't interested in variable stars? They're great. It's an asymptotic giant branch star, and what it's doing is blasting, as it's dying, it's blasting off a heap of gas from its surface into an envelope around the star, making for all kinds of weird and spectacular spectra, strange behavior. It's kind of a not quite regular variable. It does weird, unexpected things, which make it worth watching. Just because the regular variable stars, they're pretty much covered by robot telescopes now. It's the stars that do weird stuff that demand individual attention for you and I to take our telescopes out and actually look at these things. And speaking of which, we have to have a variable star because I wouldn't do this talk if I couldn't talk about them. RR Lyrae is the one I've picked. It's a really useful, famous variable star or variable star type. It has pulsations that depend on temperature and the opacity of the gas within the star. Pretty technical stuff. I'm not going to try and explain it because I I don't understand it well enough to explain it and be sure that I'm right. But there's all kinds of resources online where you can get the full details. RR Lyrae itself goes from 6.9 to 8th magnitude every 14.4 hours. And it's scientifically interesting because it has a really solid mass luminosity relationship. So you can use that as a standard candle to measure distances to globular clusters and even other galaxies. Because it changes brightness so fast, you really want to use a photometer to get accurate measurements. Doing a visual measurement, you can do it for your own entertainment, but by the time you've finished comparing it to your A, B, and C stars, the brightness will have already changed and your data is going to be useless. As some Canadian content, Helen Sawyer-Hogg, famous in the RASC, famous at David Dunlap Observatory, made much of her career measuring RR Lyrae stars, especially in M13. So, if you want to perform an action of tribute to this great Canadian scientist, go out there and point your telescope at M13 and see if you can spot some of the RR Lyrae variable stars. And as always, aavso.org, the American Association of Variable Star Observers. That has all the details, and once you've placed your measurements, you can record them on the website there. They get to the scientific community. The data you have recorded and submitted gets to be part of real science. So that's something that we should all be a little bit excited about. Coming up in the world of spaceflight, JWST is coming online, still going through tests. I saw a very impressive picture of a bunch of galaxies that it had taken today. We're not quite seeing real science yet, still during the calibration phase, but we're all expecting amazing things. Italian LARS 2 satellite going up on July 7th. This is one for measuring all kinds of geographic changes on the Earth with interesting lasers. Get some good science out of there. Sometime within the next month or two, China's Wentian space station module, a science module, will be sent up and attached to their space station. I haven't seen the Chinese space station going overhead. I've seen the ISS many times, but I don't know if it's if it orbits over us or not. SpaceX's Starship orbital test flight also coming up. I don't think we need to bother with all the individual SpaceX flights. They're almost mundane at this point. The ISS is passing over all night long from now until August 2nd. We're at the time of year where the Earth is tilted just the right way. The ISS is pretty much in daylight anytime it passes over us. So get lots of chances to see a spaceship fly overhead full of astronauts and cool science. If you're looking for specific times and locations, heavensabove.com is where I get mine. Obviously, the ISS, you can't predict ahead of time where it's going to be. They adjust the orbit. I don't know exactly where you are, so go there and get the information, fresh and ready for yourself. And what if it's cloudy, or you're tired and the telescope mount weighs too much and you don't feel like dragging it out there for a mere 2 hours of darkness? There are all kinds of citizen science projects going on at zooniverse.org. There are dozens of projects. Ones I thought looked interesting this month were Aurora Zoo. If we do get some aurora tonight, go out there and have a look and compare it to the stuff that other observers have put up there to be classified by you. Cloud spotting on Mars, disk detective, which is looking for planetary disks around other stars, or protoplanetary disks. And Jovian Vortex Hunter kind of looks like a cool one too, where you get images of Jupiter, and your job is to go through and look for storms and vortexes and all those interesting weather things that make Jupiter so fascinating. So that's what we have this month. I hope we all get out and do some observing and enjoy some clear skies. Thank you very much.
Andy, great talk as usual. Great coverage of all that's happening in the sky for the next month or so. Let's go to Emma with questions from our audience.
Great. We got a couple of questions from the audience. The first one comes in from Ellen Pappenberg, who is wondering if there are any infrared filters. In thinking DSLR, because a long time ago they used IR film.
My understanding, and this is not a solid one, is that your basic SLR comes with a filter over the chip to filter out infrared light, and what you want to do is go in and take it out. Now, that may be 10-year-old information. I haven't done any IR photography myself, so yeah, that information is worth what you paid for it.
Great. The next question comes in from Eric Briggs. He says, I would have picked Scorpii as a variable star to discuss tonight because it went in from an outburst for the first time since 2010 on June 6th from magnitude 17 to 8. However, it's already gone so dim that it's invisible to the eyepiece already.
Well, I wish I had known about that in time, but to be honest, the way my house and the trees around my house are situated, I can never see Scorpius from my backyard observing spot. So that one, I wasn't even watching for it. So that's my bad. Yeah, whoever was doing the sky this month, last month, should have predicted that this star was going to go into outburst and warned us in time, right?
Well, that's it for questions. Thank you.
All right.
Okay, thank you.
Thanks again, Andy. Appreciate the talk.